Demonstrating acid-base reactions with the baking soda vinegar rocket, presented by Timothy Lyons. Who doesn't love a rocket launch? Anybody? Today, I'm going to demonstrate how to build a rocket that flies 20 feet into the air using everyday household materials and without using fire or combustible materials, so it's safe for kids. It's also a very cool trick, and it demonstrates the fundamental principles of acid-base reactions. Here are the supplies you'll need: a plastic water bottle, duct tape, 4 pencils, white vinegar, baking soda, a cork or a carrot, and a paper towel. Step 1, rocket construction. So you can see here, take plastic water bottle, tape 4 pencils to it in such a way that the bottle can stand up with the hole facing down. It's easiest just to look at the picture and copy. Step 2, making the baking soda engine. Take a piece of paper towel, put about half of a tablespoon of baking soda into it, and roll it up into a tight little tube so it can be dropped through the hole in the bottle. Step 3, add vinegar to the bottle. So as you can see, I filled up the water bottle about 1/3 of the way with white vinegar, and I'm using the carrot as a cork at the top. So what happens when you add baking soda to vinegar? Vinegar, which is known as acetic acid, is a weak acid, CH3COOH. Baking soda, also known as sodium bicarbonate, is a weak base, NaHCO3. The balanced equation for their reaction is seen here. NaHCO3 plus CH3COOH yields CO2 plus H2O plus sodium ions plus CH3COO negative. This is an acid-base neutralization reaction, which means that the hydronium ions, which are produced by the acid, combine with the hydroxide ions produced by the base to produce H2O, which both eliminates the acidic H plus ions and eliminates OH negative hydroxide ions, meaning that the pH is being neutralized. So as you can see, that's the outcome of the balanced equation, but there are actually 2 reactions taking place here. The first reaction is an acid-base reaction. Vinegar reacts with sodium bicarbonate to form sodium acetate and carbonic acid, and you can see the balance. You can see the equation here. The sodium acetate, NaC2H3O2, is a salt, and it's one of our end products. But the carbonic acid is not one of our end products. Carbonic acid is a combination of carbon dioxide and water. When carbon dioxide dissolves in water, it exists in equilibrium with carbonic acid. So the equilibrium statement for carbonic acid and water is H2O plus CO2 is H2CO3, and H2CO3 produces CO2 plus H2O. So when H2CO3 spikes, this reaction leans to the left, which means that it rapidly produces massive amounts of CO2 and H2O in an attempt to reestablish that equilibrium. So our second reaction is carbonic acid decomposing to produce carbon dioxide gas and water. So H2CO3 yields H2O plus CO2, and a whole lot of CO2 very quickly. The carbon dioxide escapes the solution as bubbles. In the closed container that is our rocket, it causes a rapid rise in the pressure until the cork is expelled along with the gas, creating propulsion. So let's see the experiment in action. Sometimes things don't happen exactly as they're supposed to, but no one was hurt. So as you can see, I'm putting the baking soda engine into the bottle, which contains vinegar. There it is. I'm plugging it with the carrot. And now I'm going to shake it up to mix the baking soda and the vinegar. It's starting to foam. And ooh, it fired before I could set it down on the ground. And yet the experiment worked. So, we don't need to watch that again. And sorry, one moment. In conclusion, baking soda is a base and vinegar is an acid. When combined, their hydronium and hydroxide ions seek to neutralize one another and form H2O. This process may require several steps, and the results may be explosive, so be careful.